This problem, we are supposed to find the function y that satisfies this initial value problem. dy dx is equal to x plus 1 over x squared, and y of 1 is equal to 3. All right, for this problem, I have that dy dx is equal to x plus x to the negative 2. And so if I find the antiderivative, y will be equal to, I add 1 to the exponent for x squared, then I divide by the mu exponent, so I get x squared over 2. And then for this second term, again, I would add 1 to the exponent for negative 1, and then divide by the new exponent, which is negative 1. And I can rewrite that as x squared over, I can rewrite that as x squared over 2 minus 1 over x. And I forgot the plus c here. That gives me the general solution here. So x squared over 2 minus 1 over x, and then plus some constant to be determined. Now, how do I determine the constant? I determine the constant by the second line. So y of 1 is supposed to be equal to 1 over 2 minus 1 over 1 plus c. So I have that 3 is equal to minus a half plus c. And so c is equal to 7 halves. And so I plug that into the top line, my formula for y, and so I get that y is equal to x squared over 2 minus 1 over x plus 7 halves. And that is the answer. Now, I could stop the video here, but let me do a check to confirm that this actually indeed works. What happens when I take the derivative? The derivative of x squared is 2 over x over 2. The derivative of negative 1 over x squared, that's going to be plus 1 over x squared. And then the derivative of 7 halves is 0. So the derivative indeed checks. I get x plus 1 over x squared, which is what I'm supposed to have. Also, if I plug in 1 into my function y here, I would get 1 squared over 2 minus 1 over 1 plus 7 halves. So 1 half minus 1 plus 7 halves. 7 halves plus 1 half is 4 minus 1, and I get 3, which was the initial value that I was supposed to have in the problem. So the answer that I've boxed in green here, that is the final answer. The extra work that I did here was a way of confirming that the answer is correct. And if you have extra time on the exam, you may want to do this to double check your work.